Hey everyone, in this video we're going to cover the second review of Math 2. I guess you could call these the basics for moving into Math 3, making sure you know some very important content. In this review we're going to cover polynomials and solving quadratics. In regards to polynomials, we're going to be talking about adding, subtracting, multiplying, factoring polynomials. And then when it comes to solving quadratics, yes, there are multiple methods to solve quadratics, but in this video I want to really emphasize the idea of solving by factoring, as we see factoring repeat itself throughout multiple concepts moving forward in the math world. So with that said, and then I wanted to make sure that there was an emphasis on the difference between what a factor is and what a solution is by factoring. Okay, so we want to make that clear. With that said, let's go ahead and go on to problem number 1. Here it says simplify and write your answer in standard form. So in this case, notice that we are taking a polynomial and subtracting another polynomial. We are not multiplying these polynomials together. We're saying this thing minus this thing. And so when we see parentheses here, we need to realize that there's a coefficient of 1 out front of those parentheses if there is nothing else. So when we distribute that 1 into those parentheses, as it were, we would end up in the first case with the same thing, because 1 times anything is itself. For the second thing, we actually have a negative 1 out front, so we're going to distribute that negative into all of that. So we end up with negative times negative 11v is positive 11v. Negative 1 times positive 13v squared is negative 13v squared. And then negative 1 times negative v squared is positive v squared. From here we're going to combine like terms, and we're going to list things in standard form, which means the highest exponent is going to go first. Well, the highest exponent out of all of these is a cube raised to the third, so we're going to combine those first. What's negative 6v cubed minus 13v cubed? Well, that's negative 19v cubed. And then the next order would be v squared, so that'd be 7v squared plus v squared, or 1v squared, that's 8v squared. The next one is 11v, there's nothing to combine there, so we'll just carry that down. And then the last thing is the constant. Remember, the constant is the idea that we're seeing the exponent descend, 3, 2, 1. Even though it's not present, it's implied a 1. Well, what's the exponent here for the v? It's v to the 0, because v to the 0 is 1, and 1 times 5 is 5. We just don't express it because it's not the simplest form. Anyways, that is our answer for number 1. For number 2, we're going to be doing the same type of thing, except notice we are adding the two polynomials instead of subtracting. So when we go to distribute that positive 1, nothing changes. The parentheses just drop. And so you can imagine there's a positive 1 here, and when we distribute this in, we're still going to get negative 4 minus 14n squared minus 8n to the 5th. And then same thing on this front thing, everything stays the same. From here we're going to combine like terms and list it from highest order first. So n to the fifth is the highest order, so that would be negative 20n to the 5th. Remember, we're basically saying, okay, we have negative 12 of these guys and negative 8 of the same guys. So how many do we have altogether? Well, negative 12 and negative 8 is negative 20. For the next order, the highest order is squared. So 2n squared minus 14n squared. Well, I have 2 of them, and I subtract 14 of them, and I end up with negative 12 of them. And then the last thing are the constants. So 14 plus negative 4 is 10. So that's our answer for that one. Moving on, let's go ahead and move on to multiplying polynomials here. Oops, let's get to the problem here. Multiplying polynomials. Notice we have 3n plus 4 times 6n minus 7. Well, to multiply those polynomials, we need to rewrite it in what it actually means. So remember how to rewrite this in a form that we can distribute. We're going to write this as 3n, so 3n times the term 6n minus 7, and then 4 times the term 6n minus 7, or the binomial 6n minus 7. From here, if we can break it down like that, we take the 3n and multiply it by all of this, and we take the 4 and multiply it by all of this. That's what's going on here. Then we can see distribution pretty easily. We end up with, when I distribute, 3n times 6n is 18n squared, and then 3n times negative 7 is negative 21n. For the second one, we end up with 4 times 6n, which is 24n, and 4 times negative 7 is negative 28. Combining like terms in standard form, we're going to end up with 18n squared plus 3n minus 28 because we're combining the negative 21n and the positive 24n. For number 4, it's the same thing, but notice we have a binomial times a trinomial. So we're going to break this apart just like we did on number 3. We're going to say 8x times the entire trinomial plus 1 times the entire trinomial. And then from there we can see the distribution quite easily. So 8x times x squared is 8x cubed. 8x times negative 4x is negative 32x squared. And 8x times 2 is 16x. Then we distribute the 1 to that trinomial. And so we'd end up with actually x squared minus 4x plus 2 because we're just multiplying by 1. We'll combine like terms here. The highest exponent is 3 and there are no other ones, so it's just going to be 8x cubed. The next highest exponent is the x squared, so we got negative 32 of them and 1 of them, so that's negative 31x squared. The next order is 16x and negative 4x, which is 12x, and then the last thing is the 2. And so that's our final answer. It's written in standard form, highest exponent first, and declining from there. So that's how to multiply polynomials. You're going to be doing a lot of that next year in Math 3. For number 5, we're going to be going in reverse. We're asked to factor this trinomial. So our goal is to make it look like we have two binomials that are multiplying together. So remember, the first thing we do when we factor, we look for a GCF. In this case, the GCF is 1. So there's nothing that we do with the GCF. If the GCF is 1, then we move on to the next step. And the next step is to deal with the factoring of a trinomial, right? Quadratic factoring is what I would refer it as. So to do the quadratic factoring, remember we do the big X. The number that goes on the top is A times C. So A is 3 and C is 18. So you end up with 54 on top. And then the B value, which is negative 29, goes on the bottom. Now we're looking for the thing that multiplies to 54 and adds to negative 29. So I'm going to go ahead and list all my factors of 54 off to the side. Well, the factors of 54 are 1 and 54, 2 times 27, 3 times 18, and 6 times 9. So all of these two terms being multiplied together will give you 54. We're looking for the combination that can add up to negative 29 or subtract to negative 29. We'll worry about signs in a second. But we can see that if I add or subtract 1 and 54, I'm going to get 55 or 53. I don't want that. I want 29. If I add 2 and 27, I get 29. And so that's probably the case. If I add 3 and 18, I get 21. If I subtract them, then I'll get 15 or negative 15. So that doesn't work. And then if I add 6 and 9, I get 15. If I subtract them, I get 3. So that doesn't work because we were looking for the 29. So we can see that the 2 and the 27 work. So we're going to put those numbers down. And because we are multiplying these two numbers to get to positive 54, that tells us that these two numbers must either be positive, both be positive, or both be negative. Because we want them to add up to negative 29, they would have to both be negative. From here, that's just a method to help us identify those two numbers in order to factor. We actually haven't done anything to factor yet. We're just using this as a kind of a model to help us understand what's going on or help us see it a little bit easier. But from here, we're going to take these two numbers, the negative 2 and the negative 27, and we're going to replace the middle term, the negative 29r, with two terms that will add up to negative 29r. So we're going to replace them with negative 2r and negative 27r. So you notice that the first term, the 3r squared, is the same, and the positive 18 is the same. The only thing that changed is that negative 29r turned into a negative 2r minus 27r. So it's still the same thing, it's still equivalent, it's just written a little bit different. Now, from here, we're going to group these things. So we're going to group the first two terms, and we're going to find the greatest common factor out of those two terms. The greatest common factor here is r, and then we're going to divide the 3r squared and the 2r by r to see what's left over, and we're left with 3r minus 2. A good thing that you're always going to want to do is to distribute back in just to see if you did it right. R times 3r is 3r squared. R times negative 2 is negative 2r. From here, we're going to do the same thing on the second term. We notice that the GCF here is 9. The question is, should this be a positive 9 or a negative 9? Well, the way that I approach this is that I know that this inside binomial must match this binomial over here. So this must say 3r minus 2. That doesn't mean we just make it happen. We have to make sure that the math is sound. But we know that if this is going to work, that this first thing must be a 3r. It has to match the 3r here. So then that will help us determine the sign of this guy. So if we have 9 times 3r, if this was positive, positive 9 times 3r gives you a positive, where are we? A positive 27. I don't want a positive 27, I want a negative 27. So that tells me that the 9 must be a negative value. And then from there, we would say, okay, negative 9 times what value gives you positive 18? Well, that would be negative 2. So we're almost there. We've got what we need to write our factors. Notice that the 3r minus 2, the thing in the parentheses here, matches the 3r minus 2 in the parentheses here. That's a good thing. If that works out, that means you did something right. If it doesn't work out, then you got to go back and figure out what's going on. Now, the two factors that we end up with are found. One factor is found from the outside numbers, the r and the negative 9, so that's one factor. And then the other factor is just the 3r minus 2 that these match to. So whatever these two are, they share the same thing, goes in the second factor, and whatever's outside the parentheses, the r minus 9 in this case, is the other factor. So we have just factored it. And you can see the reverse, you can see distribution reversed in this process. If I was to ask you to simplify this and put it in standard form like this, you would break it apart. You'd say r times 3r minus 2, there's that. And then you would say negative 9 times 3r minus 2, there's that. And then you would distribute the r into all of that. That's how we got this. We distribute the negative 9 into the 3r minus 2, and that's how we got that. And then we combine like terms. So it's just the idea of distribution, but we're working backwards. So factoring is just reverse distribution, if you want to look at it that way. All right, for number 6, we've got 16x squared minus 6x. Remember, you always look for a GCF. Well, what's the GCF in this case? The GCF out of 15 and 6 is 3, and the GCF out of x squared and x is x, so the GCF is 3x. Because we have a GCF here that's not 1, then we can take our original binomial or trinomial or whatever the polynomial was and divide each of the terms by 3x. So what would we say? We'd say 3x times what gives us 15x squared? Well, 3x times 5x gives us 15x squared. And 3x times what gives us negative 6x? Well, 3x times negative 2 gives us negative 6x. And so from here, we would notice that, okay, we took the GCF out. Now we look at what's left over, the 5x minus 2. Is that factorable anymore? Well, there's no more GCFs that I can take out, other than one, but that doesn't do anything. The question is, do I have a trinomial or a quadratic that I can continue factoring? Up here, we had a quadratic that we were factoring. Down here, there's no quadratic left because there's no x squared left. So this is actually done. We have factored it as far as we can. Okay, for number 7, again, we're looking at factoring here. Factoring is an important part of moving forward in mathematics. I use it in my calculus class constantly, consistently, and it needs to come off as second nature to students at that point. So keep in mind, this is not something that we're just doing because we learn it now and we can forget it later. It's something that we're going to use over and over and over again. All right, for number 7, again, we're looking for a GCF. The GCF in this case is a 4. So we're going to take all of those terms and divide them by 4. So we take the 4 out and we're left with 7x squared minus 10x minus 8. From here, we have to ask ourselves, is there any more factoring that can be done? Well, there's not a common factor because we already took the greatest common factor. But is there any quadratic factoring that we can do? And the answer is probably yes, because there's an x squared. And so we're just going to focus on the 7x squared minus 10x minus 8 for the next few steps, and we're going to factor that. So we're going to set up our x. Remember, a times c goes on top, so it's going to be 7 times negative 8, which is negative 56. And the b value is going to go on the bottom, so that's negative 10. We're going to list our factors of the 56. We end up with 1 times 56, 2 times 28, 4 times 14, and 7 times 8. Well, out of these, which one can give me a 10? We can see that the 4 and the 14 can somehow make up a 10. So I'm going to put those numbers down. It's going to be 4 and 14. Now we'll look at the signs. Well, because the top number is negative 56, and these have to multiply to negative number, well, how do I get two numbers to multiply to a negative? That implies that one of them has to be positive, and the other one has to be negative. Because the two numbers have to add up to a negative number, that means that the bigger number must be the negative one. So we got a positive 4 and a negative 14. We're going to rewrite our trinomial, our quadratic, so that that negative 10x is replaced with the two values that we found here. We end up with 4x minus 14x in the middle. And again, the 7x squared and the negative 8 are still there. So this expression is the same as the 7x squared minus 10x minus 8. It's the same value. It's just written differently. So from here, we're going to do our grouping. The GCF out of 7x squared and 4x is x. The remaining amount after we divide is 7x plus 4. The next group, the negative 14x minus 8, well, the GCF there is a 2. But now we got to ask ourselves whether it's a positive or a negative 2. So we write in parentheses, we write 7x because we want that to match the term in this guy. And so that's going to help us figure out the sign here. Well, if I have a 7x, what sign does this need to be to get to a negative 14x? It has to be a negative value. And because this is a negative value, and I have to multiply it by something to get to a negative 8, that tells me that something is going to be a positive. And so now we know we did it right because the 7x plus 4 and the 7x plus 4 match. And so our factors are, one of them comes from the outside, x minus 2, and the other one comes from the inside of the parentheses, as long as they match, of 7x plus 4. Again, if these numbers do not match on the inside, then something is wrong, and you got to go back and figure out what that is. All right, for I forgot one thing. That 4 that we originally factored out, we have to keep that in our final answer, because if that 4 isn't there and I just distribute the x minus 2 times the 7x plus 4, I'm only going to end up with the 7x squared minus 10x minus 8, not what I started with. So I need to carry that 4 as a greatest common factor out front. All right, for number 8, this is asking us to solve. It's not asking us to factor necessarily. That the end result is not for us to find factors. The end result is for us to find solutions. But in the directions that you had on the Google form, it said solve by factoring. So we're going to go through that same process. Remember, the first step in solving by factoring is to set the equation equal to 0. Well, it already is equal to 0. What I mean by that is that you have to move everything over to one side so that the entire expression equals 0. It's already equal to 0, so we're going to go through our factoring. We're going to look for our GCF. Our GCF in this case is 1. We're going to go through our x values. 7 times 8 is 56, and then the b value is negative 30. We're going to list our factors of 56. We got 1 times 56, 2 times 28, and 4 times 14. And 7 times 8. The 2 and the 28 will make the 30. Now we look at the signs. Because I want a positive 56, that means these are either both positive or both negative. Because I want them to add up to negative 30, that means they both have to be negative. Then I'm going to expand my quadratic, so I got 7x squared minus 2x minus 28x plus 8. I'm going to group the first two terms and look for the GCF. The GCF there is x, and the leftover is 7x minus 2. The GCF on the second set is 4, and then because I want 7x to be the first term of that binomial, that tells me that the 4 must be negative. And because I want a positive 8, when I multiply this out, that negative 4 times what gives me positive 8? Well, that would have to be a negative 2. Since the inside of those parentheses match, I did something right. My factors are then x minus 4 and 7x minus 2. Now, if this was the previous problem, we'd be done. We have factored. But this is saying to solve. Okay? Factoring is fine. But the end result will usually be, really the ultimate goal is to solve for x somehow, is to figure out a specific answer to an x value. So what we need to do from here is what's called the zero product property. Because we are multiplying two terms, the x minus 4 and the 7x minus 2, and the result is 0, that means that one of those numbers, one of those terms must equal 0. For example, if I said 7 times something equals 0, well, that something must be 0, because if the end result is 0, that means one of the terms that are being multiplied is 0. Well, because x minus 4 is being multiplied by 7x minus 2 and the result is 0, that means either x minus 4 is 0 or 7x minus 2 is 0. And then from there we would solve each one of those equations separately. So I'm going to add 4 on the first one, and we end up with x equals 4. The second one we're going to add 2, so we end up with 7x equals 2, and we'll divide by 7, and we'll leave that as a fraction of 2 over 7. So our answers are x equals 4 and x equals 2 over 7. Those are solutions. Now we can go deeper with this, and we can ask for x-intercepts if this was a function that we were trying to graph. We can ask where two functions intersect, and so we'd end up with a coordinate of somehow, but that's not the context of this problem. This problem was just an equation that we were trying to solve. And so when it says solve the equation, you're always going to get something that says x equals or something equals. All right, moving on to number 9, same thing, solve by factoring. So in this case, you notice that we have an equal sign in the middle of everything. So in order to solve by factoring, we have to move everything over to one side so it's equal to 0. So we're going to subtract the 10a from both sides. We end up with 2a squared minus 10a minus 48 equals 0 because we want it in standard form. We're going to look for the GCF, which is 2. The leftovers would be a squared minus 5a minus 24. And then we're going to go through our factoring again. The top number is negative 24. The bottom number is negative 5. We can list our factors of 24. The results are going to be 3 and 8 because we want that to add up to negative 5. So that means 8 is going to be negative, 3 is going to be positive. We're going to go ahead and expand. So we end up with a GCF out of the first two terms of a, and the leftovers are a plus 3. The GCF out of the next term is going to be 8. It'll actually be a negative 8. And then the leftover will be a plus 3. The factors there are a minus 8 and a plus 3. But don't forget, we had that 2 that we factored out as a GCF, so we want to roll that down here. So we're going to put the 2 there and then set it equal to 0. Now in this case, how many terms are being multiplied to get to 0? How many multiplication signs do we see? We see 1 in between the 2 and the a minus 8, and we see 1 in between the a minus 8 and the a plus 3. So that means we are multiplying 3 separate terms to get to 0. That means each one of those terms must be equal to 0. That's how we're going to solve it. We're going to set each of those terms equal to 0. So we end up with 2 equals 0, a minus 8 equals 0, and a plus 3 equals 0. Now, we could approach this the same way, but notice this first equation, it says 2 equals 0. Well, 2 doesn't equal 0. If it were to say something like 2a equals 0, then we could solve for a. But there's no a in this equation. This is just a claim that says 2 equals 0. Well, that's nonsense. 2 cannot equal 0, so we're going to just disregard that equation. If it was something else that we could solve, we would use it. And when you get to Math 3 and you talk about higher order polynomials, you're going to get something other than a constant out front there. Anyways, we're going to solve the other 2, so we're going to add 8 to both sides, so we end up with a equals 8. And then we'll subtract the 3, so we end up with a equals negative 3. So our two answers are negative 3 and 8. All right, last problem, number 10. Again, we're going to solve by factoring, so we're going to look for the GCF first. You notice that the GCF here is n, and so when we divide the term by n, we end up with n times n plus 2. And therefore, there's no quadratic factoring left to do. It's already factored. And so from here, we're going to take our two terms that are being multiplied, the n and the n plus 2, and we're going to set each of those equal to 0. So in the first case, we get n equals 0, and in the second case, we get n plus 2 equals 0. Now notice, this is different than number 9. In number 9, we had a number out front as a factor. A number equaling 0, we had a 2 equals 0. That didn't make sense. But this does make sense. N can be 0. N equals 0 is a solution to this equation. For the second thing, we're going to subtract 2, so we end up with n equals -2. And so our end result is -2, n equals -2, and n equals 0. So those are the all the problems for the second review of basically the key concepts of Math 2. Go ahead and ask me for any help if you need any through Zoom or email me. But I hope that this helped you out. I hope that you have a better understanding of everything, and I will talk to you again later.